Okay, so remember, I'm recording, so, ask questions if you think of them, okay? So for the people that aren't here, or that aren't grading. All right, so we did this yesterday, just a polynomial function. We evaluated it when x was 3. We said that was the same thing as minus f of 3, okay? So now, we are fixing to do something weird that you have never done before, okay? So it's not going to be a big deal in this section, but it's going to come back up later. I don't even remember if it's this chapter or the next chapter, okay? And then it's going to be a huge deal. So it's like they're doing a little teaser right here, okay? So just a little bit. So example 3. We're going to do what's called synthetic. What does synthetic mean?
Fake.
Yes. Synthetic substitution. Now, I'm going to tell you this, okay? I don't like it when they do this, but I have to call it this because my test generator comes from this book. And so at this point, this is what they call it. So if on a test, that's what they're going to call it. But then they're going to change the name of it. I don't know why. I never call it synthetic substitution, but they do right now. So that's what it would say. But we're going to call it later on, it's going to be called synthetic division. So it's like fake division, the best division you've ever seen. Okay? So first thing, you must have, number 1, your polynomial must be in standard form. What does that mean? The highest exponent first, and then in descending order. So yes, if it's a quadratic, it is ax squared plus bx plus c, okay? But remember, we're not just talking about quadratics, we're talking about all polynomials. So standard form is when you are starting with the highest exponent and going down, all right? It's the way we like to write things, okay? It gives us an ordered system. All right, so the second thing, all powers must be represented. So if somebody is missing, you have to put a 0 in their place. They have to have a placeholder. If you do not put a 0 in their place, you will miss the answer. Do you understand? You'll miss the answer. All right, so all powers represented. Okay, so I'm going to use this polynomial that we had up here. So we're going to use 2x to the 4th minus 5x to the 3rd minus 4x plus 8, okay? Now, the first thing I'm going to do, is my polynomial in standard form? Yes. So I'm going to go through them and I'll make sure all my powers are represented. So I just start at the highest exponent and I count down. 4, 3, 2. He's not there. So what do we have to put in his place?
A 0.
Yeah, so right here, there is really a 0x squared. I don't usually write the x squared because I don't really care about him, but I do make sure I put a 0 right there, okay? So I'm just going 4, 3, 2, 1, 0. Y'all, this one has to be there. If it doesn't have, what is this called?
A constant.
A constant. We did it yesterday, okay? We talked about it yesterday. This is called a constant. If the constant is not there, you have to put a 0 in its place. If my polynomial just looked like this, you couldn't say, oh, 4, 3, 2, 1, boom, I'm done. Everything has to be represented. So that starts at the top and it goes all the way down to 0. You can't exclude the 0. That's going to come back up later on, and it's going to cause some kids to miss problems on a worksheet. I'm going to remind you again, because we all know you have to tell you something more than once, right? Okay, so not this time, it won't hurt you because I didn't trick you, but next time I will trick you. All right, so here we go. Now, here's the cool part about synthetic division, all right? Fake division. In regular division, you have a house, right? Okay, in fake division, oh, it's better. It's like retirement, you got a porch. Okay, got a big porch. Now, all we're doing synthetic division, it gets rid of all the fluff and stuff. I don't need the X's and all that kind of mess because where they are, that determines what their exponent is, okay? So that's why they had to be in standard form. So I'm going to write these on the porch. Leave a line right here because we're going to put stuff there, but we're going to write there on this line. So I'm writing my coefficients. 2. What goes next?
-5.
Perfect. What goes next?
0.
Okay, are you with me now? All right, I'm writing my coefficients. 2, -5, 0. That's why I did that, so I didn't forget him. Okay, what goes next? Perfect, and 8. Okay, now I'm going to use 3. Okay, and the reason I'm using 3, I'm dividing by 3, is because of this 3 right here. Okay, that's where I got the 3. I didn't just like go, I think I'll use 3. I used 3 because they used 3. All right? So watch this, guys. Here's the way you do synthetic division. You're going to bring down this first number. You always bring down the first number, and here's where you start. Now look up here, and I'm going to tell you what we're going to do, and then we'll do it. Okay? Are you looking?
Yes.
So here we go. We're going to multiply, write it down, and add. Multiply, write it down, and add. Multiply, what else? And then, y'all are so smart. All right, so here we go. So multiply, it's 2 times 3.
6.
And -5 make.
1.
And now what do we do?
Multiply.
Multiply. 1 times 3 is?
3.
Write it down,
Add.
and you get?
3.
Okay, you do the rest of it. Okay, you got it?
Yes.
Okay, so we multiplied, 3 times 3 is 9. 9 and -4 make 5. Are you with me? 5 times 3 is 15, and 15 and 8 make 23. People, look at this.
Whoa.
What? Isn't that the coolest thing? This number, we're gonna go, later on, you're gonna learn what this number really is. He's my remainder. Okay, that's really what he's gonna be. Later on, this all becomes very, very important. But right now, they're just kind of saying, hey man, this is a different way of substituting a number in. Look at these numbers we had to work with. 162, 135. Oh, you see any big numbers here? No. Cool way.
Does that work every time?
Yes, every stinking time. But remember this. If you do not represent all your powers, you will miss the answer. Because if you leave this column out and you go to here, you can see that you will not get the same answer. Okay? So they're kind of just introducing you to it. It's not a big deal. All right, so is everybody okay? Synthetic division. Pretty cool thing. Easy way to get something. On the worksheet, I got a worksheet. Oh, and I wrote number 26 on the board because I don't know, 26 took off. Okay? So, but 26, here's what it says. Use direct substitution. That's what we did up here, right? Just directly substituted it to evaluate the polynomial function for the given value of x. Then check your answer with, what does this say? Synthetic substitution. Okay? Look, we just did that. So what are they asking you to do? They're asking you to practice this just a little bit. Okay? So you got an example. Everybody understand? Okay. So I'm starting on another sheet of paper because I put that all together. But whatever. All right, so we're fixing to do something a little bit different. This is a brand new skill, Algebra 2 skill. It's going to pop back up again next year in your next math class. Okay? It'll be easier next year, right? Because it'll be the second time you talked about it. Okay, so we're going to talk about end behavior. Okay, end behavior. Now, how many ends does a graph have?
9.
What? How many ends? Like, like where it starts and where it ends, right? Aren't those two? Yeah, so there's two. Sometimes we call them left hand and right hand behavior. Okay?
Yeah.
Everybody raise your left hand. Look, some people had to look around. Which one? Which one? All right? Left makes an L, people. Left makes an L. All right? If you don't know that, that's one. And I write with my right hand and pledge allegiance with my right hand. Okay? So however you want to do it. So end behavior. So there's two ends to my graph. I'm going to be talking about what that graph is doing on the left-hand side and what he's doing on the right-hand side. Okay? Now this is what's going to determine it. if I have an even degree function, or if my function is an odd degree function. Am I using what we learned yesterday? Oh, yes, we are, people. Okay? So, how do I tell the degree of a function? We learned this yesterday.
The highest.
The highest exponent. So the big guy determines what you are, okay? So you look for the highest exponent. If that highest exponent is an even number, 2, 4, 6, 8, 10, 12, blah, then that's an even degree function. If it's an odd number, 1, 3, 5, 7, 9, etc., that's an odd degree function, okay? Now listen to me. People, your function is either gonna, okay, well, I'm just gonna say this. Do y'all know some odd people?
I like how she whispered it.
Okay, we all know some odd people, right? So, I know, we said, okay, so everybody knows some odd people. Why do you think that they're odd? Because they're what?
They're weird.
Why, they're different. You think they don't think they're odd, they think you're odd, okay? Because they're different from us. Y'all listen to me, an odd degree function begins and ends how?
Different.
In different directions. Okay? An odd degree functions, he's odd, people, he's weird, he's different. So he begins and ends in different directions. So an even degree function, he must begin and end how?
Same.
Yes. Begin and ends. Yes, see, you've already done some. Begins and ends in the same direction. So Kevin said, like a parabola, like a quadratic, that's an x squared. Think about parabolas. They either open up or they open down. They're beginning and ending in the same direction. Oh, we've done odd ones. Linears. That's an x to the first. One's an odd number. How do all lines end? In different directions, right? One's going down, one's going up. All right? Everybody okay? Okay, so we've already talked about this. We're gonna take it further than that. Okay? Let's talk just about the even degree functions. All right? Even degree functions. Now, we're gonna take two into consideration. All right? So I'm gonna make me a little chart, because I love charts. I can look at a chart really fast and go, I know exactly what it's talking about, okay? As opposed to a paragraph or something, all right? So even degree functions, tell me what you know about them.
Even numbers.
And what do you know about the graphs?
They end in different.
Okay, so they begin and end in the same direction. Every time I write it and say it, I remember it better, okay? Every time you do something as you say it out loud, that helps your memory. So if you don't have a good memory, you need to be working on that. So let's talk about his leading coefficient. Uh-oh, this is another thing from yesterday, okay? Tell me about what is a leading coefficient?
The
Coefficient of the highest exponent. Thank you very much. So the highest exponent is determining my degree of my function, and the leading coefficient is the coefficient or the number in front of that highest exponent. You with me? Okay, so let's say that my leading coefficient is positive, or my leading coefficient could be negative. Do you agree with that? It's either going to be positive or negative. Okay, so did your mother ever say, look where you're going, look where you're going, turn around and look where you're going? That's what this thing is telling you. He's telling you where he ends up going. Now, when I say where you end up going, would I be talking about left-hand behavior or right-hand behavior? Because we read from what? Left to right. Do you understand? Does that make sense to you? We read a graph just like you read a book, from left to right. So where you end up going, that's what this is telling you. So this lead coefficient being positive is telling me that this guy ends up going up. What does this guy end up doing? Going down. Now watch this, watch this. Because he is even and he begins and ends in the same direction, I now know his left-hand behavior. What does it have to be? Same direction, so going up. What about this guy?
Down.
Going down, same direction. Okay, so let's look at some pictures besides those, because those are just little cheats. Okay, so here's my graph. All right, I'm going to do an easy one first. Make you feel comfortable and at home, right? A parabola with the leading coefficients that positive. What have we said previously? He opens up, right? Okay, this is saying the same thing. The even degree function says that he begins and ends in the same direction. Because his leading coefficient is positive, his right hand behavior, or my Arkansas vocabulary says, he ends up going up. So he has to begin from up. Do you understand? So however you like to say it, I don't really care. Let's look at this guy over here. Okay? He's an even degree function, so he has to begin and end in the same direction. His leading coefficient is negative, so his right hand behavior goes down, and his left hand behavior, because he's even, has to go down also. So he could look like this. Oh, crazy guy. Okay? Crazy. We've not ever seen any like that, but that's what we're fixing to do. Okay? We're fixing to graph polynomial functions, and that's what's going to happen to them. Okay? Are you with me so far? Everybody okay? All right, we're going to come back and write some stuff right here. Probably one of the most difficult skills. And I taught it a little different this year, so I'm going to see if that goes a little better. All right, so the next thing we need to talk about is odd degree functions. Are you with me? Okay, now what do we know about odd degree functions? Okay, so begin and end in different or opposites. I don't care which word you use, it's your notes. Okay, so we're going to do the same thing. We're going to make us a little chart. Going to have two graphs, obviously. And we're talking about my leading coefficient, the sign of the leading coefficient. Okay, over here, we're going to line them up. This is going to be a positive leading coefficient. This is going to be a negative leading coefficient. Okay? I like to do a little cheat. It's just for my brain. Okay? So he's an odd degree function. He's a first, third, fifth, seventh. Okay? His leading coefficient is positive. What is his right hand? Where does he end up going? What's his right hand behavior? Up. If his right hand behavior is up, what's his left hand behavior? Down. Okay? In pre-cal, we call this rises and falls. Those are the words that we use. Okay? We don't do that in here, but in pre-cal, we'll learn how to do it with that right hand and left hand behavior, and then we'll do it the way we're fixing to do it in a little bit. It's a little more difficult. All right, over here, my leading coefficient is negative. What's my right hand behavior? Down. If my right hand behavior is deaf, I'm down. He's not deaf. And he's an odd function. What's my left hand behavior? Very good. Okay, so I'm going to draw some wonderful graphs for you. We've seen stuff like this before, right? Okay. Right hand up, left hand down. Okay? This time, my leading coefficient's negative, so he's going to end up going down. It means he has to start going up. What? It's a wacky guy. Okay? All right. Now, the next thing I want to do is I want to talk to you about how I can tell you what this graph is doing on the left-hand side and the right-hand side. We've used the words left-hand behavior and right-hand behavior, okay? But this book, and a lot of times they're going to express it in a different way. So I want to tell you some terms that I'm going to use. One of them you've never used before, okay? But the rest of them, I'm just, the way I say it, you're going to know what it is, okay? So the one that you've never used is this one. This arrow to the right means he approaches. Okay, so approaches. That means he gets closer and closer and closer to. Are you with me? Okay, what is, f of x is the same thing as what? Y, okay? We're gonna use f of x. We're not gonna use y. It would look nicer with the y, but they're gonna use f of x, so I'm gonna teach you with f of x. Okay, you're gonna see f of x more. Why? Because we're talking about functions, people, and that is function notation. All right? So, let me ask you this. If you're talking about the left-hand side of a graph, who goes left and right, x's or y's? X's. Everybody with me? X-axis goes left and right, x's go left and right. If I'm talking about the x, tell me on the left, what is x approaching? If you keep going all the way to the left forever and ever. Negative infinity. Y'all, this is another way of saying left-hand behavior. If I say x is approaching negative infinity, then I'm talking about the left-hand side of my graph. Does everybody understand? Okay. If I say x approaches positive infinity, what am I talking about? The right-hand side of your graph. Are you with me? Okay. Which way do y's go? Up and down. So if I say, I'm going to say f of x. Sorry, I used y, and I'm trying to remember to say f of x. If I say f of x is approaching positive infinity, which way is my graph going? Up. If I say f of x is approaching negative infinity, which way is my graph going? Down. All right, anybody got a question? No question? Okay, so I'm using, this is kind of like a legend. Do you see what I'm saying? So I'm using this legend right here. I'm using that legend right there, and I'm going to write what this graph is doing, okay? I'm going to put the left on the left-hand side and the right on the right-hand side. I'll start off and I'll write those, but then after a while I'll quit writing them. All right, so over here on the left, if I go to the left, what does x have to be approaching? Negative infinity. Y'all, x is approaching negative infinity, so that's this way. I'm talking about this side of the graph. So x approaches negative infinity as y approaches what? Yeah, because he's going up on the left-hand side. Does that make sense to you? Yeah. Kind of a weird way to write it. Now look, I wrote mine in 2 lines because I like it better that way. But look, even if they write it this way, guys, x approaches negative infinity as y approaches positive infinity. This is the same thing as this. Yes, f of x, sorry. Y'all watch me because I keep saying y, sorry. F of x approaches positive infinity. Okay, are you with me? All right, so over here on the right-hand side, I'm going to do it with you, okay? What is, if I'm on the right-hand side, what does x have to be approaching? As f of x approaches what?
No, positive.
Yeah, he's going up, so positive infinity. Okay? So, you think you're ready to do one by yourself? Okay,
Yeah.
so over here, I'm just gonna write the left and right one more time, and then down here, I'm not gonna write it, okay? So, because they're not gonna say that, all right? They're just gonna say, tell me the end behavior of the graph. And normally we do left hand first and right hand second, all right? So you do the left hand. I'll give you 30 seconds. Hey, Mr. Ryan, how are you?
Doing good. They both come in the same.
Yes, they should be, we hope, if I wrote it down right.
The Y and the X for the left both come in the same.
Yep, left and down,
Yeah. Okay.
on the right,
It'll be opposite.
yes. All
I
right,
haven't seen you all week. Well, I heard you twice.
People usually hear me before they see me.
But your jokes this week were really good.
Sorry?
Your jokes this week were really good.
You know, every now and then, yeah.
Don't
You
make
see
me
the
laugh.
hairline and second-hand sword. Those
Second
are really
storm.
good. Now listen.
I don't know. You go.
Don't interrupt.
that's okay. So left hand behavior, x approaches what? Perfect. As f of x, thank you, Kevin, approaches negative infinity. Sorry, I don't know what happened to me.
Negative.
Yeah, I put negative and then my brain goes, you forgot to draw your arrow, but I didn't. All right, are you with me? So I made 2 arrows. All right, right. 20 seconds. Don't panic. Okay, so on your worksheet, here's what I did. On like the first problem or the first and second, I did this. I'm telling you how I want it, okay? On the next problems, I didn't write it because I'm going, take my hint, people. I told you how I want it, write it like you're supposed to. Everybody got it? Okay, so it's these, well, actually I didn't, but on the test I did. But here, they told you how they wanted it, all right? And they wrote it backwards, but I don't care how you write it. They wrote f of x first and then x, but it doesn't matter, okay? So x approaches what if I'm on the right? Positive infinity as f of x approaches perfect. Okay, down here, I'm not writing left and right, okay? Tell me what the left-hand side says.
Oof.
X approaches.
Whoa.
X approaches negative infinity as f of x approaches, it's going down, negative infinity. You do the right. All right, you okay?
With the ones that are like this, won't it just be the left and right will be complete opposite everyone? Like the,
For
yeah, for the algebra because they're
Well, these aren't opposites.
No, like.
Make the
go
left-
Oh, you
left side
mean
and
that,
right
oh,
side.
yes,
Yeah.
yes, they will. Yes, they will. X approaches what?
Positive.
Positive infinity as f of x approaches positive infinity. Very good. Everybody okay? Do this one, both sides, right now. I'll give you less than a minute. We're doing good on our time.
Eleven five?
25. Check your answers. Check my answers. Everybody okay? Anybody have a question? No? So can y'all do these? These are, y'all listen to me. I mean, this is easy when I'm guiding you, right? It's not quite as easy when you're just out there all alone, okay? So, but that's the way it is on a test, so make sure you practice enough. Katie?
Understand the right math, I wasn't here yesterday, so how do we get it in a parabola like that?
We
I'll draw you a picture. Or, watch what we're fixing to do. We're fixing to apply this knowledge right here, okay? So, we're gonna apply it 2 different ways. The first way I'm gonna apply it is, I'm gonna give you a picture and you're gonna tell me what you know, okay? So this is example 4. And then I will give you a polynomial and then we'll graph it and I'll tell you what I'm requiring. Okay, so here it is. Now when I first do this, I'm gonna say some things that you're gonna be like, what? Okay, but then I'm not gonna tell you how I'm doing it. I'm gonna see if you can figure it out, okay? So, here's my first one. Don't cheat and look back at your notes. Use your brain, okay? Use your brain. So, here's the first thing. The first thing I'm gonna ask you, don't say it out loud. Give everybody a chance to think about it, okay? The first thing I wanna ask, is this an even degree function or an odd? Don't say it out loud. What do you say? Why?
Because they're different.
Yeah, he begins and ends in different directions. He has to be an odd degree function, okay? I'm gonna tell you this, and you don't have any idea how I know this, but you're gonna figure it out. It is at least, okay, I mean, it could be more than, okay? It is at least a third degree equation. It could be a fifth or a seventh, but I know it is at least a third degree equation, okay? Tell me this, what is his leading coefficient? Positive or negative?
Yeah, probably.
How do you know?
Because
He ends up going up. He begins down, but I don't care where you begin. Y'all look, this is just like life. It doesn't matter where you start. It doesn't matter where you come from. It doesn't matter what kind of family. It can be broken. It can be messed up. It can be not so great at your house. But in the end, it's how you finish. Can you make your own home with a wonderful family?
Yeah.
Yes, you can. If you don't have some good friends, can you make good friends and be a good friend? That's what it's about. Finish strong. Finish this class strong. Okay, we're getting to the end, people. It's almost time to say goodbye. All right, finish
We'll
strong.
see you next year.
All right, here's your next one. Are you ready?
Maybe.
Here we go. Oh, I don't know.
Oh, thank you.
Okay, these are the things that I'm wanting you to know.
Roller coaster designer.
No, I would never ride a roller coaster. I would never. Okay, are you ready?
Yes.
All right. Degree, even or odd?
Even.
Justify your answer. That's right. He begins and ends in the same direction, right? Could I say they're both going down?
Yes.
Did you restrict what an even function was when you said that? Because you're telling someone that it's not even unless both of the ends go down. Do you see what I'm saying? You have to be careful how you say it, because how you say it, other people are listening to you, okay? So if you said, well, they're both going down, that's why it's even. Then if I made them both going up, someone would say, that's not even. You see what I'm saying? So be careful how you say it. All right, so even, they begin and end in the same direction. It is at least, anybody want to take a guess? 6. Tell me what you did.
Count how many times it changed direction.
Oh, okay. So there's 2 different ways to do this, okay? So Montana said she counted how many times it changes directions. That's very true, okay? That is what you would do. 1, 2, 3, 4, 5, 6. So what did some of you, the rest of you do?
I counted the humps.
I counted the humps and did what?
I didn't know how.
There's only 5
Add
How long did it string on?
You just add 1, okay? It's easier for me to count the humps. 1, 2, 3, 4, 5, plus 1. It is at least a 6th degree polynomial. Now we're going to talk about in just a minute how this could be an 8th degree polynomial or a 10th degree polynomial. Yeah, it sounds crazy, but it could be. What's his leading coefficient, positive or negative?
Negative.
Very good. All right, here's the last one. Degree, at least a what? Leading coefficient, don't say it out loud. And leading coefficient, positive or negative? All right, you got it? All right, when you're finished, look up so I know that you kind of are putting put your pen down or something, so I know you're okay. All right, so, degree, even or odd?
Odd.
Why?
Opposite
direction.
Very good. Begins and ends in different directions, opposite directions, whatever you wanna say, okay? He is at least a what? Fifth? 1, 2, 3, 4. I count humps because it's easier for me to count humps than it is to count changing direction. But actually, technically, it is because of that, it changes directions that many times. Okay, so it's a better way to say it, it's just easier for me to count the humps, okay? Leading coefficient, positive or negative?
It's gonna be negative.
Very good. Okay, so let's talk about the number of humps that something has, okay? The number of humps, it's gonna be, how do I find the number of humps? The degree, what?
Minus one.
-1. At most. Okay? At most. Notice this says at least because we went backwards, but this is at most. So if I have a 10th degree equation, he will have at most what? 9 humps. Okay? So watch this. This is what I'm talking about. This is why these words come into play. All right? X to the 8th. This is an 8th degree polynomial. Everybody agree? His leading coefficient is positive. He will begin and end in the same direction, and that is up. He will have at most how many humps? 7. You know how many this guy has?
7.
1. This guy right here will look exactly like a parabola. Okay? Except for one thing. Okay? The bigger this number gets right here, the flatter and wider this space down here where the vertex is, he gets. So, like guys, here's how you remember. The bigger this number, the older you are, the flatter and wider your butt. Okay? I mean, that's pretty much what happens. Yeah, that's it. But it makes y'all remember that, okay? The bigger this number is, the flatter and wider he gets out. So where do all those humps come in? The more junk I give to this guy,
They lap up on each other.
Well, that's too much.
the more
Wait,
I
what's
do
that,
that,
four?
the more, well, yeah, because you still got a fourth, a third, a second.
Yeah.
No, you had 2 5s.
Oh, so,
I just checking, making sure.
Or you can
It's okay.
combine them.
It's not
Or
that
you can
deep.
combine like that.
yeah, you can buy
Yeah.
it. That was cool. Okay, so but the more junk I give this thing, the more it creates those humps in there. Okay? So the more stuff you put, y'all, you don't put anything in there, you got a hump. Okay?
Gosh.
So look at this one right here. If I do x to the third, y'all know what that looks like? Oh, please tell me it was on a memory test you had. Looks like this right here.
Oh, yeah.
Okay? X to the third. So what's x to the ninth gonna look like? Y'all, he's gonna look the same, except what's gonna happen in here?
Flatter the butt, man.
Flatter, he's gonna be flattening
Flat-
out,
flat butt.
widening up, okay? But he's still gonna do the exact same thing. What if I wanna make a bunch of humps like this guy? This guy right here. He's odd, okay? What if I wanna make a bunch of humps? Then I'll need to put some more stuff in there. Are you with me? That's pretty cool. Okay, so that's one of the really cool things we learned today. All right, let's see if we can get to the next cool thing. We have 10 minutes, so we're good. So now we're going to graph polynomial functions. I'm gonna tell you what I'm going to be looking for, because if I don't find it, I'm taking points away from you. You will always support your graph with a T-chart. Okay, you will always support your graph with a T-chart. You slap a graph on a coordinate plane, and you don't support it with a T-chart, then my brain goes, oh, they tried to copy that out of the calculator. They're like, no credit. All right. So the first thing I want you to do is I want you to find the zeros. We're gonna start off pretty easy, okay? But even if I didn't, you would know how to find zeros on the calculator. Yes?
Yes.
Okay. The second thing I want you to do is I want you to find what we're going to call relative mins and maxes. Okay, relative mins and maxes. So this is what I'm talking about. Let's say we have a graph like this right here. Okay, now, is this a max? No, y'all look, this thing doesn't have a maximum. Do you understand what I'm saying? He doesn't have a maximum, but relative to this general area, is this a maximum point? Right here. Yes. Is this a relative max? And how many relative mins do you see?
2.
2, one here and one here. So those are what I'm talking about. These right here are relative max, and these right here are relative min. It doesn't really have a max and a min, but I can't write and talk at the same time. But relative to that general area, that is a max or min, and that's what we're gonna use to graph. We're also gonna use what you know about end behavior. Okay? Now, skip a little space because I'm gonna talk about one thing. This is the coolest, y'all, this is not in our book. Okay? Okay. It's in the PreAPAlg book, but it's so neat and it helps us graph so much that I like to talk about it in here. Multiplicity. I mean, please, it's even fun to say. Alright? So multiplicity. So we're gonna work one example. F of x is equal to, now watch, I'm gonna write it really nice for you. X plus 2 quantity times x minus 1 quantity squared. Okay? And we're gonna graph it. Obviously, I'm going to need a teacher. Okay, so let's see what you can remember. All right, now let me tell you what multiplicity is. Multiplicity is how often a factor, these are factors, right? Do you understand? These are factors. Factors are things that are multiplied together. So how often a factor occurs. Now this is what's so cool about it. If your factor occurs an even number of times, then at that 0 or the 0, your graph will bump. Okay? It's going to bump that 0 and then go back in the direction that it came from. If your factor occurs an odd number of times, then at the 0, it's going to cross. Okay? So, here's the first thing I'm going to look at. I'm going to look at what we studied. Are you with me? I've got about 4 minutes, so pay attention. Everybody with me now? Okay. So, the first thing I want to do is I want to talk about the degree of this function. I didn't multiply it all out. But do you know properties of exponents, people? So, what's the degree of the function?
LOL.
What?
It's positive.
Yeah, it's 3. Look, where you're multiplying, when you multiply, what do you do with your exponents? You add them. What's 1 plus 2? 3. Let me show you another way to look at it. When you square this binomial, will you get an x squared?
Yeah.
When you multiply an x squared times an x, what will you get? Okay? So his degree is 3rd, and that makes him odd. Tell me what that tells you about his end behavior.
They're gonna be
They're going to be different, okay? What about his leading coefficient? Is it positive or negative?
No.
What, look, y'all, when you square this, what do you get? When you square this, 1, you get a positive x squared. When you multiply a positive x squared times an x, what do you get? A positive x to the 3rd, okay? So what is it? Leading coefficient, positive or negative? Positive. So look what that tells me. That tells me that this guy ends up going up, and he starts where? Going down. See my little cheat right here? This is my cheat, all right? So, look at this. This is my factor. What's my root? What's my 0? 1. Very good. It always changes its sign. And not only is it the 1, but it's a what? What did I tell you?
One square.
No, not one squared, one as a, how many times does it occur?
Twice. Oh, so it's a double root.
Oh, it's a double root, very good, very good. So he's a double root. Because y'all listen to me, if this is a cubic equation, Freddie Goss told us it has how many solutions? 3. Yeah. He said you gotta have 3 solutions. Here's 2 of them right here. What's the other one? -2. Where should my zeros be in my T-chart? So -2, 0, and 1, 0. If you wanna write double root, that says, hey, I found all 3 of them, lady. Okay? So -2 and 1. Now watch this, watch this. Y'all, he starts down here from the bottom. Do you agree? Here's my cheat. He starts down here, and he goes up. What is the multiplicity on this -2? It's a 1. Is that even or odd? Odd. What does he do at the odd? So he goes up here and he crosses it. I don't know how high he goes. I'm gonna have to figure it out. But he is gonna come back down and he's gonna hit this guy right here. What's the multiplicity on this 1? He's a square. He's even. So what's he gonna do? He's gonna bump him and then he's gonna go back up. And that's good because he's supposed to end up going up. Now what's the only thing I have to find? That relative max right there, right? So I use my handy dandy calculator. Alright? I go to y equals. There's my function. I've already put it in for you. I'm gonna graph it. I'm looking for this max right here. I don't have to find this man, people. Already, he's on my T-chart. Second and calculate. What am I looking for? What's he asking me?
Left bound.
Left bound.
Go
So
that
get to
way.
the left. Enter. Right bound. Get to the right. Enter. Please tell me you know what that number is.
It's 1.
No. What is it? If you write -.9999999 whatever, I'm gonna mark it wrong. Okay? It's -1, people. He's just a pixel thing, so he got as close as he could. So -1, and he's at 4. So -1, 1, 2, 3, 4. What a beautiful graph. Lovely. All right. You ought to be able to finish your worksheet. Okay? It is due on Monday. I don't care if you're in class or out of class. Okay? I'm gonna send out a remind. If you didn't make it to class, then you better watch the YouTube video. You better figure out how to do it. Okay? I want it done. Yes, this is 5.2 and 5.1. They're both on YouTube. Okay? Have a good weekend, guys.
You too.
Hey, Caleb, will you stop the video up there